Hello and welcome to CG Visuals. My name's Zach, and in this video we're going to learn how to create a realistic flamethrower inside of After Effects and Trapcode Particular 3. So without further ado, let's get started. Now, the project file we're going to be working with today is available from VideoHive as part of our Trapcode Flamethrower collection. So let's break things down and figure out how to create this effect. So we're using After Effects CS6, and the fire is being procedurally generated using these 4 Trapcode Particular layers here. We've got one for the embers, the fire, and also an emission fuel effect here. Now all of these particle systems are being driven by these sprites. So to follow along, you can simply download these sprites from the description, link in the description video, and you want to grab these 2 mob files. So once you've brought those into your project window, you'll want to create a new composition. We'll go for something like 1920 by 1080p. And we're going to be using a spotlight as an emitter for Trapcode Particular. And this will just give us a greater range of control over how the particles are being emitted. So we can create a light by going new, create an After Effects light here. And we want to make sure we give it a name like emitter. This will allow Trapcode Particular to recognize the name, and we'll also have to specify that name in Trapcode Particular. Make sure we're choosing the light type to be a spotlight, and we're using an intensity of 25 and 15 for the cone angle. And I believe this value here will also affect the directional spread. So you can see how we're having better control over those options. Okay, so once you've got that set up, we can also add a quick wiggle expression to the point of interest here. So if we choose something like 0.5 and for the speed and 10 for the amplitude here, we'll see how that looks. But just to give you an idea, let's increase that a little bit more. So you want to end up with something like this, and then we can start building up all of the effects and settings onto this, and this will just be a good base to see how things are behaving. So moving into the particles comp here. So don't be overwhelmed by how many layers we've got here. We'll explain what's going on in just a moment, but we'll want to start with one solid layer that you've applied Trapcode Particular to. We're going to need these animated fire sprites in the same composition as our particles. So if we go to the effects section of Trapcode Particular, we'll just make sure we've got these settings. So we're using a light here. We need to choose the name of the light, and that's why we need to make sure it has the same name. What's actually quite interesting is that although we've named our light to be emitter, locate and aim, it needs to have the word emitter in the beginning of the name first. So we'll look for this name first, and then we can add another name on top of that. But if we were to change this, I believe it would probably break the whole setup. Yeah, so we need to make sure that we have that naming convention. Right, so once we know that, we obviously make sure we've got direction type set here, and the rotation of the direction will be controlled by that spotlight. So let's go into the particle section here. We're going to want to make sure we're using a sprite as the particle type. We don't need to use Trapcode's built-in sprites here, because we're going to be going to the texture tab and choosing our animated fire sprite 1, and then we're just going to choose a random still frame. It's going to pick any of these frames at random, and it's going to add some more variation into the visual look of the fire. Next, if we go to the rotation here, so we've got rotation randomization turned on here, got it at 100%. Using 1 for the rotational speed, and the rotation distribution speed will add another layer of randomization to the speed. And we can also animate this rotation in Z-axis. And I've just Alt left clicked on the stopwatch here and added a time expression. I should also mention that some working knowledge of After Effects and Trapcode Particular will be required to follow along this, because we are jumping in and out of settings quite quickly. But here we go, there's the time times 1000 expression for the rotation. Next, let's have a look at the size and opacity. So we're using 15 and 100 for the opacity and size here. But more importantly, we've got an interesting custom curve here. So the idea was to have the fire being emitted, conforming to a sort of jet fluid shape, depending on what type of fuel this is. And then as the fire progresses through its lifespan, it starts to increase in size and then decrease in size again at the end. And this animation curve here will just help to create the look of the fire that we want. And so if we look at the opacity as well, we've got a custom linear curve over life for the opacity. Now you may have noticed that some of these values are highlighted in red. So we've got the emission rate here, particles per second, the velocity, and the lifespan of the particles are all being pick whipped and connected to slider controls. So if you want to replicate that, you'll just want to create 4 null objects, and you'll want to give that is represented by the 4 null objects we've got here. So we've got one for fractal influence, that's for an effect that we're going to discuss in just a moment, one for emission rate, one for velocity, and one for fuel burn speed to represent the lifetime of the particles. In each of these null objects you want to add a slider control. So to get these pick whips set up, we're going to want to make sure we have access to the stopwatch in the layers panel. And so then if we expand our Trapcode Particular here, we can go to the emitter settings, and we can Alt left click on particles per second, which we said was going to be emission rate. So we'll drag the pick whip tool to the slider. That generates an expression connecting particles per second to our slider here. And we can do the same thing for the velocity. Alt left click, dragging the pick whip tool up here. This is why we want to make sure we've named the layers beforehand, make it a bit easier for ourselves. We've got a wiggle expression on the velocity randomization. So it wasn't enough to simply have random velocity, but we wanted to add a random factor to that randomization with a wiggle expression. Just an extra layer of variation that's going to help sell the effect in the end. And then we've got one more final setting here that we need to pick whip, and that is the lifetime of the particles. So let's pick whip that to our fuel burn speed layer. Okay, so why did we do that? Well, we're going to be duplicating this layer a lot, and then if we wanted to come back and change those settings afterwards, these sliders will globally control those settings for all of the particle systems. It would be possible in the newer version Trapcode Particular to create multiple systems in one layer. But in some cases we are actually relying on being able to use blending modes with the systems here. And it's also a little bit easier just to be able to see everything laid out. So let's continue modifying the settings of our Trapcode Particular here. We've already done the emission settings and the particles. So let's go to the physics tab. And we'll have -25 for the gravity, physics model air, and this will allow us to have some air resistance. And we can also add a turbulent effect to the particles. The most important setting here is the fade in time, because if we were to set that to default, we're going to create a more volatile look for our fire. But if we put that to 5, it will delay the turbulence effect until later on in the lifespan. And we've got the spin amplitude 35, and this will control how fast the turbulence happens, or the evolution speed. Okay, and then of course we've got some motion blur enabled, and that's really going to take us a step in the right direction. So if you've been following along, the first issue you'll run into is that no matter how many particles per second you enable, there'll always be some strays that float off and really give things away that we're using sprites here, and we want to try and create the illusion that this is a sort of more cohesive fluid simulation. So I've enabled this roughen edges effect here. So without much explanation, we can already see what it's doing. So we've got the border settings on 1, 0.10 for the edge sharpness, and this is why we created a 4th null object for the fractal influence. We're going to want to go and pick whip that fractal influence to the slider that we just created. Go to fractal influence here, Alt left click on the stopwatch. We just created a keyframe, so let's Alt left click again. Remember, we do have to have the stopwatch visible in order to be able to successfully set up the pick whip tool. 3rd time should do it. Okay, so now that's set up. So why was it important to have global control over the fractal influence of that effect? We do need this effect in order to be able to successfully pull off the fire. But if there's a circumstance where the fire is going into the camera, that roughen edges effect can cause us some problems. Let's put it down to half res quickly. So this roughen edges might work well at this sort of perspective, and we might appreciate having all these extra little breakups in detail. But as we've just seen, this is going to create some unnatural noise around the edges. Having this fractal influence pick whip to this slider here, which means in these kind of scenarios, we can simply put the fractal influence down to 0. We're still going to have the benefit of the roughen edges effect. It's still going to take care of any stray particles that come too far away from the main body of the effect, but it's going to prevent us from having that noticeable pattern around the edges. Let's reset our camera and we'll re-enable this effect. So there's a few other steps we need to do in order to get this effect to work. And we're going to add an expression to the evolution of the roughen edges of time times 150. That's not going to be quite good enough to get this effect to work all the time, so we're also going to add oh, there's that row keyframe we created. We don't need that because it's already connected to a slider. What we're interested in is this offset turbulence here. By selecting this, we can see the turbulence. Now, if we were to animate this from one position to the other, that noise would essentially be behaving the same way that a turbulent displacement would, in which the the turbulence would actually be traveling in a direction. We'd be able to see that reflected. So that's what we've done. We've animated from the beginning of the time and 50 seconds forward, depending on how long this effect might be. We've taken it from down here vertically upwards, and that's just to try and adhere to the fact that we're shooting a flamethrower in that direction and it's fire and the heat distortion is rising upwards, and that's just going to help this effect to work and be more reliable to have that effect enabled. Definitely helps to have it keyframed. Okay, so now that we've got this effect, this is where things start getting a little bit easier, because we're simply just going to duplicate this first effect that we've created. And for the original layer, we're going to put the blending mode on normal, and then the one we created above that, we're going to put the blending mode to multiply. So you should end up with something like this. You've got your two fire layers. Let's just change the color. See, these are the two layers we just created. So the duplicate version, if we put that underneath the original version, we're going to put the blending mode to normal, and the original version here, the one that's using the animated fire sprite 1, we're going to put the blending mode to multiply. And the only setting we need to change in this duplicated version is we're going to change the texture to use the animated fire sprite version 2. We could also change the random seed here so that these effects aren't a complete carbon copy of each other. I think that's what we've done here as well. So that'll give you this effect. So it's starting to get there, and this is really going to work well once we enable the color correction. It's going to give us some different variations of exposure in the fire. So we're also going to want to create this little jet of fire that comes out here, and to do that is just simply a case of duplicating the fire that we created. We're going to make a few simple changes to get that effect. We're simply going to change, let's see, we're still using fire sprite 2, so yeah, we duplicated that system. All we're going to do actually is just put the size down, whatever it was before, to 5. We're going to change the size over life, so it's more of a linear shape like this. Still got a linear curve for the opacity. And then we're going to change the lifetime of the particles here. Let's have a little quick look at what's going on here. So this value would be pick whipped to the fuel burn speed. We want to go ahead and just unbreak the connection there. You can do that just by alt left clicking on it, and we're just going to add a wiggle expression, because no matter how long the particles last for, we want this just to be a small jet. Could be like a gas effect, just to fill in that where the particles are emitted from to when they start expanding. So we've just added a wiggle expression to the life here, 15 for the speed, 0.1 for the amplitude. And of course we've got the life time at a 0.25 there, and we put the blending mode to screen. So a couple of changes there, but other than that, it's pretty much the same effect. Okay, so then if we go back to the original layer we created, we'll duplicate that again, and we're going to change that to be embers. Increase the exposure here just so you can see what's going on. So we're not going to be using the sprite this time, so first of all we're going to change the sprite to a cloudlet, and then we're going to tune the size right down to 0.5 to be these much smaller embers. The curve over life is going to be a linear graph here, so the embers are going to shrink over life, and they're also going to fade out over life as reflected by that curve. Just got the blending mode on normal there. And if we go into the physics settings, there's a few small changes we can make. to the turbulence here, just to get the embers to behave more like embers. We'll just increase the spin amplitude from 35 to 100. As for the motion blur, I've reduced that down to just 180 and -90 for the shutter angle and shutter phase. That's just to stop the particles looking too much like streaklets. Okay, so if we reset the exposure there and enable all of these layers, once we took the time to create the first layer, it was just a case of duplicating it and making a few simple alterations. So let's preview this effect and just have a look at what's happening with the animation. Okay, so we'll preview a few frames here. You can see the animation is behaving quite nicely. That rough and edges effect really doing its job there. There would be no other way to simulate this effect that we're seeing at the edge here, unless we were using some kind of fluid solver or something like that. Instead, we've just manipulated a bunch of values to try and cheat that effect. And so if we play it back, so let's see, I think we're probably going to just bring the fractal influence down to 0, maybe 0.5. Let's just try having a quick look at that again. Okay, so I think the 0.5 works okay. Now it's not quite there yet, but let's take another step further and create an adjustment layer, and we're going to create a turbulent displacement. So we're going to put 20 for the intensity and 15 for the size. And we're doing a couple of things with the offset and evolution. It's really actually pretty much the same thing we did with the rough and edges. We're putting a time expression on the evolution here, time times 250. So we've got that evolution is going to be always changing, but we need to go a bit further with it, and that's what we're using the offset turbulence for again. So this time we've got the offset turbulence is to the lower left corner of the screen here, and over time we're animating that, basically going from here all the way up to here. So now the turbulence is actually going to be rising upwards through the effect and simulating the effect of a rising heat distortion. So now these effects are starting to stack up on top of each other. So I think it's time we started adding the color correction that we need to complete this effect. So the first one that we've added here is a tint. We're going to be adding an adjustment layer, and as mentioned before, we're working in 32-bit. And the reason we're working in 32-bit is that's going to allow us to preserve a greater range of detail in the highlights. So the first effect we're going to add is a tint here with an amount to tint of 65. This is going to help neutralize some of the colors so that it plays a bit nicer once we start adding these glow effects. So the first glow is an additive glow for the core. It's got an intensity of 0.1, 37 for the threshold, and the radius of 70 here. So now when we combine that with a second glow, we're creating a two-step glow. The second glow though is using a screen operation here, and we're using 25 for the threshold. The radius is much larger, 340, and only 0.1 for the intensity. We don't want to go too high with the glow, otherwise that 32-bit is going to allow us to create some pretty insane values. Next we're going to start pushing the fire in the direction we want for the color with a curves adjustment here. Starting with the RGB, we're just creating a bit of a contrast curve here. Then we're going to go to the red channel and increase the red. Go to the green channel, We're going to take out some green here. And then we'll go to the blue channel. Of course, if we take too much green out, we know what happens to the fire. It turns into a rosé effect, which we don't want. And then, of course, we're going to take out some of the blue values as well. So that's taking us from that to that. So it's getting there. We're going to want to refine it a bit more with the tritone effect, though. So this effect is great. We can specify that we want the highlights to be white. We don't want there to be any weird shadows or anything. So we've replaced the blacks with whites here. The shadows. We've replaced the shadows with a white value instead. And then for the midtones, we're choosing an orangey colour. We're choosing this shade of orange here. And we're choosing a blend with original about 50%. So that's another step in the right direction. We can further refine it with hue and saturation here, taking a little bit of saturation out. Then we've got a levels here. This levels adjustment here, we're just using this to control the gamma. So depending on where the fire is, what the exposure of the shot is, this will allow us just to add a bit more richness into it. And then finally, we've got one more final glow here, so I guess you could call this a 3-step glow. Threshold of 60, 0.5 for the intensity, screen operation, and 700 for the radius. So this effect will complete the whole set. This is giving us a nice look to the fire. And as mentioned before, all of the settings like the lifespan of the particles we can now control with these sliders. Got the velocity here, so we can animate the velocity of the flamethrower, and that's going to allow us to create some really cool effects. As a general rule, the more you increase the velocity, the more you're also going to have to increase the emission rate. But that's quite a cool effect. You can get away with a surprisingly small number of particles now that we've got all of these different effects on there. And it's not even going to take that long to render either, even at full res. Considering we can now put a camera in here and start really customizing this effect. When you are creating cameras, you've got two options. So for example, we can choose a 1-node camera or a 2-node camera. So a 2-node camera is going to allow the camera to essentially rotate around. If we just enable the embers here, this is going to allow us to rotate around a point of origin, whereas the 1-node camera is essentially going to place the camera on a tripod, and that's going to allow us to rotate around as though we were in first person. So we should be able to find the fire here. Might just be better to create a new camera actually. Make it a 1-node camera, choose the film back size. We can dolly into the effect. Yeah, now we can actually look around the scene. As though we're in the scene in first person, we can actually now sort of inspect the particle system. Obviously, we've got quite a lot of effects there, so it is a little bit slow, but still you've got a decent amount of interactivity. Alright, so let's re-enable all of these effects here. We'll reset the exposure here. Of course, it's nice that you can increase the exposure and a little bit without the fire completely blowing out. Of course, if you, in some scenarios, it'd be quite cool to have this photographic effect, but we'll have a look at how to composite the fire more realistically in just a moment. Okay, we'll wrap things up there. Stay tuned for more content and be sure to let us know what you want to see in the comments, and thanks for watching.